This session couldn't have been put together without the assistance of these two gentlemen. So Henry Coles on your left is the inventor, creator and maintainer of PyTest, which is the package that I will be showing later on in the demo. And Philip Van Lenen works with a Ruby version called Mutant, and he's an advocate in, I think he's in Norway. So these guys, massive thanks. They helped me with this material, and they created the tools which I use. So I've been talking about the quality of tests. And so before I actually go into any detail here from me, I'd like to know just a little bit about you. So how many of you consider yourself to be developers? Pretty much everybody. The people that didn't put up their hand, what do you consider yourselves to be? How do you describe yourselves? Architect? That's it then. Okay, one architect, there's a lot of developers. Do you feel outnumbered? No, you can't see them. This is normal, okay. So how do you assure the quality of your test suite? So I guess maybe the question that comes before this is, do you have an automated test suite? So how do you know how good it is? Peer review, okay. Code coverage. Sorry? Okay, review it with the business. So one of the things that quite often we jokingly say is that we only employ really good people, and that means that we're always going to get really good codes and tests. Do any of you use TDD? Some. So we often hear as well that TDD will protect us because TDD says you never write any code unless you've got a failing test. So any of you that practice TDD will know that it's really hard to slow developers down. They see loads of things that they want to do and they don't wait for the failing test to be there. And anyway, just because you wrote the test first doesn't mean the test is good, is well considered. Peer review is, as was mentioned by the audience, that's, that and pair programming both work together to try and help keep the quality good because you've got at least another pair of eyes looking at it before it gets committed. This is one that is very common, which is QA was going to catch any problems. Now, that's obviously not keeping your code, your test suite high quality, but at least it's trying to keep stop defects from escaping into the consumer's arena. I saw an excellent little joke article not that long ago about a development method known as stack trace driven development, where you don't have a QA team and you just release the code and the people just send you the stack traces, and that way you know where your next piece of functionality has to go. And finally, good code coverage. And this I would say is probably the most common answer. So how many of you have got a continuous integration build or something of that sort? And how many of you have a coverage statistic that pops out the bottom of it? And of the 4 people that have got that, what do you do with it? Okay, nice number. Nothing? We don't let managers look at it. So it's a metric it's probably the only metric that's well known about how your tests measure up against your code. And it's hardly used, and when it is used, it's used badly. It's sometimes used inappropriately by management to beat people around the head. It can be used to break the build if it's not going up, which is also just beating people around the head. And then it's one of those laws of unintended consequences. If you force people to make the number go up, the number will go up. But whether you'll get anything out of it that's any use is not a great thing, is not assured at all. So these are the things that we say at the moment. Potentially peer review will catch these things, but most of the others are not going to assure the quality of your test suite. And certainly if you're taking on somebody else's product, you're looking at something open source, or you're trying to buy something in, or you move to another team and you want to work out whether something's good, there's very little to give you any confidence that the test suite is useful, correct, or working. For my part, I think this test suite is the best form of developer documentation. And so if I can't go to it and rely on it and get a feel for what the system does from it, then I think that we're missing something. So I think there should be, I always hope that there'll be other ways of determining the quality of the test suite. So let's focus on code coverage to start with, because I'd like to, I really want to take this one apart right at the beginning. So code coverage itself is a sort of umbrella term for many different things, which includes line coverage, branch coverage, statement coverage. So there's all sorts of different coverage. And in fact, if you compile things down into, into binary or into some intermediate language, there are even more points there at which the coverage could be analyzed. And so this code coverage, does it guarantee that you can safely refactor your tests? So if you've got high code coverage, in the 90s, does that mean you can refactor things? No. We've got a man shaking his head in front. Not at all. It doesn't mean either that you can trust the code, the test suite that you've inherited. It doesn't mean that the tests are effective. So when I have another hat on, I do a lot of training of people in how to do good unit tests and how to work in a test-driven way. And I see an awful lot of modes of operation that I think lead to verbose, incomprehensible, and unmaintainable test suites. And coverage isn't going to tell you anything about that. So in fact, you could have one monster test that called every method in your application. You could have no asserts in it whatsoever, and you could get 100% code coverage. So definitely not. It won't tell you when you've done enough. So a lot of customers work with legacy code. Are people familiar with Michael Feathers? He has a wonderful definition of legacy code, which goes, legacy code is code that doesn't have good automated tests. And that covers most of the code in the world, including the code being written today. So it'll be legacy code as soon as it's committed. And one of the problems that I see regularly is that people go, I've got this huge code base, it's got some tests, I don't know if I can trust them. How am I going to change this really important part that the business wants me to expand, modify, make more generic? And they go, well, I'd like to put some tests around it. And that's great. Let's try to put some tests around it. So we go off to Michael Feathers' canonical book, Working Effectively with Legacy Code, which I wish I was on commission for, and it should be on everybody's desktop or bookshelf. And it's got hundreds of patterns about how to work effectively with legacy code. But if you read the little bit at the beginning, he talks about, in most cases, you have to perform some safe refactorings without having the benefit of those automated tests. Because even to put the thing under test, you have to change it a bit. So that's a really dangerous thing. So you want to do as little of it as possible. How are you ever going to be sure that you've done enough there to protect that legacy code so that you can go in and modify it? So coverage doesn't help with any of these things. Animation. Doesn't. So it tells us nothing about the quality of our tests. It tells us which statements have been run by our tests. So it doesn't even tell us that we've tested those statements. It tells us that we've executed them. It tells us which statements have not been tested. So from that point of view, code coverage does give some important information. It says this area of the code has definitely not been tested. So it's a negative. It's saying this bit is really, really awful. It's so awful that you haven't even been there. But the bits that it has covered, it tells you nothing at all. Just means that you've run something. So I've really dissed coverage because I think it's important to diss coverage in the same way that Alan did a wonderful dissing of Agile certification this morning, because it's generally accepted as a useful number, and I think it's almost, it's worse than useless in most situations. However, it is extremely useful. I will tell you about what it's useful for later. So this is the suspense, this is the hook, this is the draw to stop you from walking out. I will tell you what code coverage is useful for later. Here is a very simple class. What does it do? Yes.
And then if you call reset an internal variable, it's reset.
Perfect. Exactly. It's got a count that is set to 0 and an increment that goes on there. And this is the output of running some unit tests, the mutation testing over it. So what this is saying is that we have done some work here and checked it, and it all works out fine. This is not being tested at the moment. It's not very helpful because I haven't shown you the tests yet. The tests are here. Can you spot what's wrong with these tests on inspection? So this is the code review that Austin was talking about. It doesn't hit 10. Now, that I would suggest is an observation that is easy to make in this particular situation, but it's something that when you scale it up into the large, when you've got complex logic, when you've got complex bounds conditions, becomes harder. So what mutation testing is going to do is try and help us identify these automatically so that if they slip through code review, we'll catch them later on. So a gentleman called Lipton, back in 1971, made a quote, said this quote: "If we want to know how the test suite has properly checked some code, then deliberately introduce a bug." So this is injecting a defect. I really want to point out the date here, 1971. So mutation testing is not new. Mutation testing has been around in the academic world for getting on for 50 years. But we're not using it in production, in our work, in our day-to-day existence. So I'm going to do a few definitions now, just so that we know, we're talking off the same page, trying to generate this ubiquitous language. So a mutation is the deliberate introduction of a bug by changing the code under test. So you think about it as, if you think about mutations in the genetic world, maybe infrared causes some sort of DNA problem. And here we're talking about changing the code under test, and it's going to be changed in a way that is significant in some way. And a mutant is a version of that code under test that has a single mutation. So this is also important. We don't go through the code and make billions of mutations to it. We make a single mutation, we make a single change to the code, and that is a mutant. It's a candidate mutant. And at this point, the presentation becomes horribly non-PC because this is a very anti-mutant talk. Okay, so the intention is, this is Amtrak Wars, where they spend a lot of time killing mutants. But the intention is that we want to kill our mutants. That's what our mutation testing is about. We generate a mutant, we run the unit test suite over it, and if the unit test fails, it kills a mutant. So we take the mutation test, we run our test suite. If any test fails, the mutant's dead, and everyone rejoices. If no test fails, then the mutant has survived. And so it's as simple as that. We take code, we make a change to it, we run our tests. Did the test catch the change that we made? But you think about doing that to a complex piece of software. You're not going to do that yourself. You're not going to do that manually. And it would be too time-consuming and too tedious. So you have a tool to do it. And mutation testing generates lots of mutants. So I guess the first thing that a mutation testing framework or tool has got to do is identify what mutants where to inject the mutations. What should it do to generate all these mutants? And then with each mutant that you generate, you run your test suite over it and check to see whether it fails or not. So then you have to record and interpret the results. So we can see there may be a lot of mutants. We're running the unit tests many times over all of those mutants. And then we have to do something with the output of that is going to deliver us value. So Jerry Weinberg, in a book of his called Perfect Software and Other Illusions, made an excellent quote, which I love, which is that software testing is about exercising the software and gathering information with the expectation we're going to do something with it. So this is the problem with coverage, in that we gather information, we don't do anything with it. And this would all be fine, but it's pointless unless we're going to do something with the outcome. So if we don't do anything with the outcome, there is no point generating and gathering in the first place. So I guess Alan said that this morning. Why collect documentation if no one's ever going to read it? Why collect statistics if you're never going to use them? So we want people to gather us information. We want it to be put to good use. And so it's important that what we get out here is easy to use. because otherwise we might do lots of this and get cool and groovy stuff and then forget about it. So here we go back to our class that we were looking at earlier, the counting class. And so we're going to pretend that we are a mutation generator. So we're about to create a mutant here. And we're going to take this statement, the greater than or equal than 10, and modify it to be greater than 10. So that is a modification, a functional modification of the code under test. So this is a mutant. And now we will do a little bit of code demos. So folk who are sitting at the back, you have another option to come and see the code at the front. Otherwise, it might be hard, but there we go. So just to demonstrate, we're in the counting class. We've got window issues. So if it's even too small for the people at the front, please let me know. So here we have a class. Can you read that? Yeah. And this is the class that we're talking about, that we're wanting to test. And here we have the tests that we've already shown, which are, and our astute colleague in the front has already noticed that there should be a problem. I have a build.xml file, which I won't go into any great detail here, but basically it invokes the PyTest framework that I was talking about. And here, all I have to do is run ant over it, and it build fails. Isn't that just great? That's not supposed to happen. And sorry? It was a mutant, yeah. It's kind of weird. Oh, I see. Okay. I created new windows. The demo effect is a wonderful thing, isn't it? So when you're using the right version of Java, everything's good. And so that ran a mutation test. It did a build, it ran the unit tests, it ran the mutation tests. And as you can see, like so many automated build tools, it's somewhat talkative. And it's output a lot of information, which we'll just briefly look over, simply because I think it's worth having a look at. And so it tells you that it's not even doing the verbose logging, so that's useful to know. It's sending one test class to the slave, so essentially there's a whole bundle of implementation underneath, and it generates some mutants. So we're creating the mutants here, and it completes in around a second, and then it does some coverage and dependency analysis. So there's the clue as to where the coverage might be coming in later. And then it invokes some different mutators. So we'll see this in a minute, but there are a number of different mutations. So you can't always just look for greater than equal and turn it to greater than. So at each function point in the code, the mutation library will look at the statement there and check through its candidate mutations, or mutators, and see which ones are relevant and could be applied. So here's one of them, conditional boundary mutator. So that's the one that we're invoking this time for the particular failure that you recognized. And it says that it generates one mutant. It didn't kill any of them, not surprisingly, because we saw that, and a whole bundle of stats. And then here we have a return vals mutator, which is going to change values that are returned, and that one got killed. Doesn't say it in this report where it was, but we'll see that in a second. And then there's a negate conditionals mutator which got invoked, which got generated and killed. So this is the textual output, and this, I think, fails the test that I was talking about at the beginning, which is this is not a useful way of looking at information. It will be hard for us to do anything about it with this. So let us go off and open a file, because that's always fun. And where am I here? Am I in the right place? No. And it is 1420, so it was that one. So it generates an HTML report, which talks about line coverages, mutation coverage, and you can break it down by package. So you can imagine if you had a large piece of software, you want to break it down by various architectural layers and class structures that you would use already. So I click through to that, and it shows me that it breaks it down by class within that Java package. And then it gives me a list of what happened. It analyzes every line. It gives you in green every line that was actually executed. It shows you the mutations it shows you where mutations were applied. It shows you where mutations were killed. So here too, it shows us that there were 2 mutations generated. The changed conditional boundary survived, whereas the negated conditional got killed. And down here at the return, it replaced the return integer 0 with 1, and that got killed. There's down at the bottom, there is a summary of those mutations and the results. The interesting thing here is that we still get the benefit of coverage in that it says, well, look, actually, there are no tests that hit this reset method. So, because you're mainly software developers, I know you'll be itching to fix this. So what tests? Let's have one test to fix that conditional boundary mutation. Test 10. So let's just go and do that then. Use the thing. Should count. Okay, so now we can go off and do this again. And click through. Hey, goes green. And so this begins to give you the feel for how this would work in a working practice. So has anyone ever worked in a language which has got a lint program? Have you ever tried to apply lint to a pre-existing code base that has never had lint applied to it? This is the same sort of thing. Okay, you don't want to be doing this over 100,000 lines of code that has never been mutation tested before. So the ideal time to start playing around with mutation testing, although it's not the best, it's not where you get the most value from it, but the ideal time in my experience is when you're starting a project. Because when you start a project, you start small, you run it, you fit it into your process, you deal with them as it comes along. It's like continuous integration, it's continuous mutation testing. If you have to do it all at the end, well, what do you do in lint when you have to do that? You turn off loads of stuff. And so PyTest comes with a whole bundle of stuff to allow you to turn off things. And that's typically what you would do. So PyTest allows you to choose which paths you want to mutation test. So you can choose just a package or a subset of packages. It allows you to add or remove some of the mutation operators so you can make it more or less useful. What I'm really saying is it's really simple when you look at it like this, but if you've got 10,000 of them, you're going to be fed up pretty quickly. So let's also sort out this reset one. What should we put in for a test for that reset method?
Count 10, verify you get 1, reset, verify
Yeah.
you get 0.
So actually, we always want to see a test fail, don't we? There you go. So that should fail because the test should be one. The test should return a reset. Good. So then we go in. Do a lot of stuff. Ping down. And there we go, we're all green. So we can go home feeling that we've done a great job, that we've got not just 100% test coverage, but we've covered all the mutations, and our tests themselves covered any errors that we could have put in. Now we're going to, that's a big statement to make, and I think we'll talk through it a bit more as I go through. But this is guaranteeing us that based on the mutations that we're doing, at every point in the code where a defect could have been injected, our tests would catch that.
Some years ago when I was at PGL, this group there, this we use just.
Yes.
The two problems we had was scalability.
Yes.
Quite big databases, and then probably had the app stuff.
Yes.
The other problem we had was ensuring termination.
Yes.
When you mutate, you got quite a few cases.
Yes. Yes.
Does test
It does. It handles all of these things. And can you hold those thoughts? I'm pretty sure I certainly cover the first question. And if I don't actually cover the third one in the session, I will cover it at the end. So let's go back to presentation mode. So these are the mutation operators that currently ship with PyTest out of the box. And if you don't tell it otherwise, these are the ones it will run. And as you can see, there are quite a lot of them. And I'm not going to go into details here. So this is an area of academic research. PyTest itself ships with another 3 experimental mutators that Henry has decided are either too unstable or too time-consuming to ship without. But you can turn some on, you can turn some off, you can mix and match. So you can tune it yourself. But as you can see, it does an awful lot of things. So we've seen the conditionals and the negate. It also removes conditionals in some situations, mutates some maths, fiddles around with the incrementation, so plus plus and plus by 1. It removes inlining. We've seen the return values mutator. The void method call, so if it's a void method call, it will just not call it and see whether that affects the outcome. So there's an awful lot of things that go in there. The PyTest website is pytest.org. They're each documented in full there. And so I encourage you, if you're interested to dig deeper, to go and have a look at them. But like so many packages, it does the right thing out of the box. And so you don't need to unless there's a specific reason for you to do so. So now I would like to come back to the talking about why the proof, or at least the background of research that leads me to believe that what seems sort of obvious has actually been found to be obvious by academics who've been trying to prove it and do it in a more structured way over many decades. So Andrews Briand at ICSI, not that long ago, 10 years ago, found that generated mutants are similar to real faults. So obviously this addresses a particular potential complaint or concern, which is it's all very well going through and mutating parts of the code and seeing whether your unit tests catch it. But is that really how faults creep in to code? So I don't know if any of you have done any research or the stats on the most common programmer errors. No, actually, yeah, let's find out. Have any of you done any reading about the stats and the most common errors? I mean, anyone want to make a guess what the most common error is? Yeah, the fence posts off by 1, sizes, so all of the things around, it all seems very simple, that'll be fine. And we just don't test the very edges. So although the mutations may look very simple, they are actually representative of the main errors. And all of our complex logic is based upon simple logic. They're Boolean machines. As far as I know, every machine you're working with is at least intended to be deterministic. That was a joke. So here's another one. This is Geist from '92. In practice, if the software contains a fault, there will usually be a set of mutants that can only be killed by a test case that also detects that fault. And that's trying to set up a mathematical equivalence between these mutations and real-life faults. And so this was, again, so this is a guy writing about enhancement of real-time software reliability through mutation analysis. And now this one's 25 years ago. So again, we're looking at, we're looking at academics who've been doing prolonged research in the field, who are saying, yes, the fact that it feels and it looks like what you're saying makes sense is actually true in practice. And a final one, again from 20 odd years ago, complex faults are coupled to simple faults in such a way that a test data set that detects all simple faults will detect most complex faults. So again, as another strong assertion, I have to just admit I'm not qualified to analyse the papers that these quotes came from because they use maths and I'm a programmer. But here we go, what does he call it? Fault coupling in finite bijective functions. I mean, I don't even know what that bijective function is. So there we go, but he's saying that sort of filling in that last link of the chain, I think I used to think was a big boundary, which is, well, you know, things never fail simply. It's always, it failed because that failed here and then it led to something failing somewhere else. And basically what he's saying, well, that's just lots of simple faults, and if you could have found those simple faults, the complex fault would not have manifested itself. So we've looked at what mutation testing is, you know, in a very quick way. We've had a slight demo, you know, high-level demo, and I've tried to underpin the thesis here with the fact that people who are more academic and know better than I agree that it's the right way to go. So, yes, please.
When you were showing the demo,
yes.
When the high-test system was putting in those mutants, did it put them in one after another, and in between each one it had to recompile the entire system and test it?
Great question. That answer is coming up as well. I'm sorry. No, that's absolutely fine. Please, I'm not trying to put people down. Do ask questions as they come up. And if I know they're going to, if I know they're coming up, I'll just defer if you don't mind, because otherwise I would be repeating. So the question here is why isn't PyTest and mutation testing in general more widely used? And the two reasons that you've effectively cover off all of those reasons is poor performance and equivalent mutations. Now, I will cover equivalent mutations further towards the end, but poor performance is the biggest one. So Owen talked about it when he was using Jester. There was recently, I don't know whether you saw a thread on the Growing Object-Oriented Software by Test mailing list where Philip Schwartz, who does an awful lot of inquiry about everything to do with testing, asked about why isn't mutation testing more widespread. And the response from Henry, who's the inventor and originator of PyTest, is, well, because until I did this wonderful piece of software, there were no pieces of software that would do it effectively. And now let's have a look at why that is. So, how bad is performance? So we started off to try and give us a sort of baseline to think about performance using Joda time. So Joda time, for those of you who aren't in the Java world, so Java is a wonderful language. It's been around for a long time. Everybody loves it, even people that work in it. And they love it so much that they really like the built-in date functions and date classes. And to help them enjoy their life and productivity even more, an open source project called Joda went off and actually created some date and time classes that do useful things. It's not a huge library. It's a small library, as libraries go. So, you know, when I'm talking small, I think it's about 68,000 lines of code. So it's small in the sense that it could be bigger than that, but it's not small in the sense that you would read it and review it in an afternoon. It is pretty well tested. It comes with 70,000 odd lines of test code. So that's quite a usual, you know, in a well-tested piece of software, in a well-tested library, that's not an unreasonable ratio of test to production code. And it takes about 10 seconds on a quite good box to compile it. So it's not a huge amount of time, but it's quite, you know, it's not insignificant either. And then the unit tests take about 16 seconds to run. Again, on a standard developer desktop. So let's assume that we're using 10 mutation operators. And here, this is a rule of thumb. Maybe there are going to be 10,000 mutations. It could be more, it could be less. It's more likely to be more than that, to be honest. So if it takes 1 second to compile each mutant, that's about 2.5 hours to generate and compile the mutants one after the other. And if you run the test suite for each mutant at 16 seconds a run, that's another 44.5 hours. So that's too long, isn't it? So that's 47 hours. Is that right? Yeah, 47 hours. which is not what you want to do in between each compile and test cycle. So let's not compile. So one of the things that obviously Java and other languages have is over maybe some of the more long in the tooth C's and C++ of the world is that they've got an intermediate bytecode. They've got libraries that allow you to navigate through that model. The syntax tree is modifiable from a program itself. So PyTest manipulates the bytecode directly. So that's why we can generate, so we can immediately eradicate that 2.5 hours of compile time. We compile it once, and then PyTest works over the bytecode and modifies the bytecode in place. So that saves you the 2.5 hours. If you have to do too much and it's taking too long, just do less. So let's not run all of the tests. So the first thing to do is let's stop when a test fails, because what we're trying to do is ensure that the test suite kills a mutant. So as soon as you've killed the mutant, you don't need to see whether any other tests are going to kill that mutant. So this can, typically when we did our research, this could halve the runtime of a test suite. But also you have to choose your tests carefully. So you saw the tests that I wrote. Those tests were testing the counting class. If I also had a GUI widget, would those tests have tested the GUI widget? No. Do I need to run them? Not if I'm testing a mutant where the mutation was in the GUI code. So what PyTest does is it assimilates and takes on board the fact that you don't have to run every test for every mutant. And so it finds the subset it finds a subset. And oops, that's not what I want to do. It finds a subset using coverage statistics. Because what does coverage tell you? It tells you which bit of the code a particular test touched. And another way of working is to parallelize the test runner. Can anyone think of a problem with parallelizing the test runner?
If they all work into one central area.
Yeah, so there are problems. But of course, your tests are unit tests, and so you'll be able to parallelize the test runner. So, so these are the things that really help in PyTest. PyTest doesn't have to do compiling, so the 2.5 hours goes out the window, and it's very intelligent about which tests it runs, which reduces the runtime massively. So this is just to reiterate the fact that choosing the tests is critical, because mutants can overall be killed by a subset of the tests, so every other test you run is waste. Now some tools have taken different approaches and haven't used coverage. They've used naming conventions, they've used static analysis, but coverage data, it's there. We have those tools. We've actually invested vast amounts of development resource into developing sophisticated coverage tools, and now at least we have a really good use for them. So PyTest takes coverage data and it only runs the tests that could possibly touch the code that has just been mutated. And so actually, I think that slide comes up with this. So we have our counting class here. We've got our count equals 0. I'm trying to wonder why, there we go. So the coverage data tells us that this line of code here is going to be hit by those tests there. And so we know that if the mutant has been created by mutating that line of code, we only need to run those tests. Similarly, we know that only these tests will hit that line, and well, this was done before we went and put in a test for the reset. That's not covered by any test. Yeah. So this was me building it. This is actually not on this machine. This was on the previous version of this machine, so it possibly would be a bit faster now. But this was running Joe to time. It generated 9,922 mutations. It killed 7,833 of them, which was 79%. And it did it all in just under 10 minutes. So it's still not something that you're going to have running in the background every time you type a character. But it's definitely feasible to put this on your build server. So you could even have it as a separate step in the pipeline so that you get quick feedback about whether the build is broken, but the next stage in your CI pipeline would tell you if your mutation testing had been compromised by that check-in or some check-ins. So definitely, there is capacity for doing that. As you see, this is with 2 threads. So if you're going to be doing it on a build server, there's no reason why you shouldn't throw more threads at it, and you would get a appreciable build increase in speed, because the unit tests should be parallelizable. So, but maybe the thing that would worry you is, well, why only 79% of tests were covered? That doesn't sound like 100%. Surely we should be incentivized to get to 100%. So why is that? So there'll be some missing test cases. Joe Time was probably not built in a strictly GDD way. It was probably built on top of something that somebody had already knocked up on the side. There are possibly areas of the code which don't feel like they warrant unit tests, so I don't know what your philosophy is, but quite often I think a test for a plain vanilla getter or setter is just a waste of space. I don't know how often I want to test. There are some constructors I don't particularly want to test. So there will be missing test cases. Some of them will be missing because you don't think they are beneficial, they don't add value, and some of them will be missing because you didn't write the tests at the time to check that functionality, and some of them will be missing because people will have gone in and added or modified functionality without modifying or expanding the relevant part of the test suite. Now this one also plays to a question of Owen's, is timeouts. So there are some mutations that will put your code into an infinite loop. And what PyTest does is that if a test disappears as a configurable amount of time, but I think it's 2 milliseconds or something like that by default, if it times out, then it will abort the test and count it as skipped, because it doesn't know whether the mutant would code it or not. And so those timeouts, again, will get reported, and you can look into them. If you've got unit tests that take a long time to run, well, that's a problem. But that's a problem in your unit test suite anyway. But you can change the configuration of PyTest so that the timeout is longer. And the final reason is to do with equivalent mutations. And this is an area that we'll cover now. So this is a different class. It's got 2 if statements, so it's a lot more complicated than the previous class. It basically checks I for being less than or equal to or greater than or equal to 100. And it says if it's less than or equal to 100, it throws an illegal argument exception. But it's greater than or equal to 100, it should do something. Now obviously we can write this code better, but can you see that there's an equivalence here? So this can be mutated to that, and functionally the code is exactly the same. So this mutant will survive, because no test could possibly find it, because any value of 100 is going to be caught here already, and it's going to behave as expected. This is a very simple case of an equivalent mutation. Just do a quick demo of how that works. So apart from Owen, who's left the room, has anyone actually used any mutation testing in their professional lives? Nope. So this is running Py or PyTest over, let's get the right one. Over this class, which we've already had a look at. So the equivalent test is, so this is the sum logic, I is greater than or equal, I is less than or equal 100. The equivalent test, it's got the same sort of problems. It's looking for an illegal argument exception at, if it's less than 100, and it's expecting that sum logic is going to, it shouldn't throw, it's not a great test anyway, it's not going to throw if it's greater than 110. And so we've run PyTest over it, and what we'll do is we'll go and have a look at the output. So again, we've got the same sort of output. We go down to the equivalent class, and it's giving us a number of problems. So it's saying here that the change conditional boundary survived. So this is exactly the same problem that we had the first time. I'm checking for 99, but I'm not checking for 100, so we can fix that very quickly. And then down here, we've got a boundary condition survived and a negated condition survived, and some logic removed to call it, and it's talking about surviving that one as well. So let's just take out the first issue. Yeah. Oops. So. And then we'll run the code. Okay, so now what we're seeing is that we've got a failure here. It's saying that nothing has killed this. Now, is it an error? So it's not an error as such, because we're not going to have, there's no test that could find it. It was never going to fail in the way that you expect it to. But it is picking up something that was inconsistent in our code. And so what could we do here? We could certainly go and make this, we could make this greater than 100. Would that be the right thing to do?
We don't really know what the original design was. It could be that somebody had changed the first if and just didn't clean up that second if.
Exactly. So what would be an equivalent for, if we were to be thinking about this, we've been pointed at this now by the mutation testing library, and we have an opportunity to do something about it. This is like a design critique. So this is not peer reviewing, this is not peer review. This is a tool saying, I couldn't find a test that verified this. And then you look at it and you go, you know something? I can't find a test that verifies this either. And it gives you the hint and the pushback to think about, is this design correct? It's actually giving you feedback on your code, on your software. And I would suggest that probably the simplest thing to do here is take that conditional out entirely. Now, it doesn't always work like that, but I think it's true to say that that is a much tidier piece of code. And now it's still telling us that something's failed, but this one is really interesting, isn't it? So this says it removed the call to this and nothing went wrong. So this is, we haven't mocked it. So essentially, if you were writing this as a real unit test, you'd use a stub or some form of test double if you wanted to assert that this behavior had happened. But what it is a void method, and so I think it is probably the void method called mutator that has just said, it's a void method. I'm going to take it out and see whether the software falls in a screaming heap, and it didn't, and it's telling us. And now we get the chance to go, do we want to write a test that will check this, or do we want to accept it, or do in fact we want to delete this call because it doesn't do anything useful? According to the test suite we have right now. So the way I think about test suites is as documentation. And the nice thing about test suites is that when they fail, they tell you one of two things. Either that your code has got a defect in it, or your test suite is not up to date. And what this is telling me is that this is not documented what's supposed to happen here. So either I have to add it to the documentation and make that documentation clear so that the next time I come back, I can see that the behavior of the system is reflected in my unit tests. Or I go, actually, I don't want to document that because it shouldn't really happen. It's one of those things that's been left over. It could be exactly as you described. Someone's been and refactored the code, and this is now no longer necessary.
What if that calls something like, I'm just being too pragmatic,
Yeah.
what if that's like called some flaws, a logging call?
Yep.
That's typically not tested because you assume you test the logging system's going to second, so you're not testing it here. So removing it is probably not going to trigger any tests, but I'm going to get a lot of noise when these tools start stripping out my logging calls. How do I deal with that?
So I'd like to go back to your initial assertion there. So how is it that you're not testing logging? So if logging is important, should it be tested?
This is just
Uh-huh.
how things are in some places,
Yeah.
right? That I've verified that my logging library
Mhm.
works to my satisfaction
Yeah.
in some separate set of
Yeah.
cases perhaps, right? And so then I don't bother checking that it's actually doing the logging in every place that I use it, because that would result in a test suite that's so massive. So taking out the logging in that case probably isn't going to actually cause any horrible problems that I bother checking in my tests, but it's going to cause this thing to go nuts.
Well, so yeah, so I'm surprised. So I think that logging should be tested. I think if you have that issue, then you need to put in something in place that you can verify whether the log call took place. I guess your point is that in a situation where you're just calling directly into some sort of static logger, you're going to get crazy stuff like that. And at that point, if this is a pain for you, then I would disable the void call mutator.
Is there a way to tell it disabled just for the, because you can probably classify all of the,
Yeah.
syntactically or lexically classify all of the logging calls and you say, don't.
Yeah, that's a good question, and it's not one that I know the answer to because I've never tried to do that. You can disable things based on the class paths of your packages, but I'm not, because we're already not testing the logging framework, so it's already been excluded from the class path. So whether it would be able to remove, whether it intelligently calls void methods in areas that it doesn't test or not, I would need to check with Henry. Sorry.
Would that kind of lead toward the idea of if the test doesn't work, don't comment it out and just assume everything's okay?
Sorry, say that again?
So I've seen this once where somebody commented out a test going, this test doesn't actually work.
Yep.
Therefore I'm commenting out this test when they didn't actually know
Uh-huh.
what was being tested and that the test was failing due to a real bug.
Yes.
And so the idea was I'm just going to comment out this test
Yep.
and investigate.
Yep.
If you do like the void removal for that one line, that's kind of equivalent where you say, okay, I understand this won't work for this particular piece,
Mhm.
and that could get eventually dangerous.
Mm-hmm. So I mean, what it's giving you is some information that you can act on, and so the information is that this void method, until we start testing the activity or the behavior that hangs off of that void method, we're not going to know whether it's an important part of the software, and we have to make a call. So I don't. Steve Freeman has done a lot of writing about logging. It's one of the bees that he has in his bonnet, and he talks about it as being an extremely important and orthogonal part of the system. Now, I don't know if any of you have worked in banks, but I've worked in banks where a whole batch process runs just with a logging system. And so I guess maybe I'm slightly skewed to thinking that actually logging is really quite an important thing to test. But I take your point that there are situations, there are places where that doesn't happen. And yes, I will get back to you on whether we can disable that. So Steve talks about logging as such, and somebody else was talking about logging recently. I'll see if that comes back to me. I will rush on anyway. So possibly we should have written this, which is what we went off and did write. So there's more causes and equivalents than void methods and guards that are unsatisfiable. So there's dead useless code. So maybe there should be a space or a dash rather than a hyphen, rather than a slash between those. But there's dead code, which we don't ever call. There's useless code, which doesn't do anything that actually delivers any value anymore. There's non-functional modifications. So within a method, there may be things going on that aren't being used in the particular site of the call that you're making. So for instance, possibly you have a method that isn't void, it returns a value, but also has a side effect. Now that's obviously not a great place to be, but these things exist. And maybe you call this method because you want the side effect, but you don't do anything with the return value. And the mutant in this particular case changes the return value. At that point, the test will carry on succeeding, even though they've made a change to the functionality of the method that you're calling. That's non-functional. Unsatisfiable guards we've seen plenty of, and internal state. So if you're caching a string or you name it, if you've got a cache of any sort, it's there for optimization purposes. We're going to modify the way that caching works. Potentially, the change, the mutation, won't affect the actual results of the code. So maybe you'll end up caching it twice. Maybe it will, you'll never be checking what gets returned from the cache. So there's internal state that can be modified by the mutation operator, and that doesn't necessarily get picked up by the test because it's not checking the internal state, it's just checking the externally observable behavior. And so what this leads us to is, I guess, the point I made earlier, which is it gives us information that allows us to focus on the areas of our code where mutations are getting through, where mutants are surviving, and that allows us to think about, is this area something that we need to improve? So I don't think that achieving 100% mutation coverage is necessarily desirable, because you get changes in your return on investment. So there are times when maybe you want to move things out of the test area if you don't want to care about it. There are times when you just accept that there's going to be a certain level of mutants that survive, and what you do is you iteratively compare the outputs of one run over another and just check the new ones that get introduced. But it's information that we can use, as you saw with the nice HTML report. It's quite navigable, so you don't have to try and deal with all the data. You can focus on a particular package or a particular area of your code base and go in and do a bit of targeted work on getting that the coverage up to scratch. Dan North is touring around at the moment with a session called Accelerated Agile. It's TM, I don't know, Accelerated Agile TM maybe, and he's got a wonderful little slide where he's got axes, the consultant's best friend, and along the bottom it's got impact, and along the vertical it's got risk, and he's got little dots and each dot represents a class or a package within your code base. So how important is it to test any one of those? So if you have really good tests up down the bottom left, is that a waste of time? And if you've got quite good tests up in the top right, is that asking for trouble? So if it's high risk and high impact, then maybe you want 100% coverage, mutation eradication. And if it's low risk and low impact, or maybe either of those, maybe you don't care so much. And so this is another tool that gives you the focused ability to go and drill down to parts of your code base, the parts that you hate the most, the parts that generate the most defects, the parts that have caused customer concerns, the parts that when someone says you've been allocated or you've got a story that touches that part of the code base, you feel that movement in your stomach as it goes down, and you go, oh please, not me. And this is a way of going in and targeting it, and you can do this before you make any changes to that part of the code base. So you can go in and run this tool and then have a look and see whether you've got enough test coverage to make you feel that it's safe to go in and modify it and change it. And in fact, now I remember why I was talking about logging. So if you've ever come across text test, or rather if you've never come across text test, I really recommend you have a look at it. It's done by a guy called Jeffrey Beach in Sweden, I think he is. And it actually leverages exactly what Austin was talking about, which is the fact that we have all this logging going on. And it takes the approach, well look, logging is fairly safe. It often doesn't, by adding or removing logging statements, you generally don't affect the functionality of your software. And it then plays into the space where Michael Feathers was asking us to do some safe refactorings before we can start putting a code base onto test. So what he goes ahead and does is says, well, text test is great. What I can do is I can generate logging statements, run my system, or run the test pack through my system, record all of that logging output, and say that this is the approved logging output. I should get this every time. And then you go and do your safe refactorings, and you run the system again, and you should get exactly the same logging output. So the tool is very clever. It compares two text files, but apart from comparing two text files, it also has a regular expression engine built into it, so it can say, filter out dates and times, because obviously logging might have dates and times. So he's covered a lot of great things. It's one of those packages that has vast amounts of documentation. almost all of which is unintelligible. But it's a great tool. So, mutants that survive have to be checked out manually. That's basically the bottom line. What mutation tells you is it tells you that if this statement is changed, I can't tell from my tests whether it's a defect that should have been caught or something that has given me an equivalent piece of software to the mutant, to the original piece of software that I started with. So the question comes up, is this a showstopper? It's been one of the things that was quoted in a lot of the literature towards the end of the 20th century. They were saying, you know, performance is an issue. We could spend a lot of time trying to get the performance better, but this equivalence mutation stuff, it's just going to be a showstopper. And they ran out of funding, they ran out of interest. What we found is that it's not that big a problem in practice. So I'm not saying it's not a problem, because it does crop up, but it's not something that every time you put in a piece of code, you end up having to weed out 50 equivalence mutations. So it's just not that big an issue. TDD itself does help prevent equivalence getting in place because the test is there to start with. And as you all know, in the TDD cycle, the first thing you have to do is have a failing test. So you guarantee that the code is taking a failing test to a passing test. And at that point, you have guaranteed both sides of that equation that the test can fail because you've seen it fail, and that your code fixes it and makes it pass. And we tolerate a few survivors. And that's, yeah. I'm sure there's something non-PC I could say about that as well. So, now to Owen's point, I guess. What about really large code bases? So we also tried it, or rather, one of our colleagues out there on the internet tried it with Common Math. So Common Math is a bit bigger. It has 177,000 lines of source code and only 109,000 lines of test code. And it takes about 8 minutes to run the unit test suite. And with 4 threads, because it's math code, there's a lot of mutations that can get generated. And with 4 threads, it actually took over an hour to run the mutation tests in totality. So we can see that it doesn't, it depends on, it scales linearly probably with the size of the code base, but non-linearly with the type of code in that code base. So it's not about lines, it's about function points. It's about the areas, places that the mutation testing library can find to apply its mutation operators. So again, an hour and 15 minutes might be okay for your CI build. It might be okay for your nightly build. You know, there's ways of working it into your system. Common Math has a line coverage of 92% and a mutation coverage again is 79%. Yeah?
Has the guy thought about working with revision control tools?
Coming! Yes.
In the base of the fact, if I've got a large code base,
Yeah.
which I've run overnight, it's taken an hour or whatever,
Yeah.
but then during the day I change one class.
Yes.
Could I run my test so that it's only executed against that one class automatically?
Yes.
So that's all that has changed since the...
Yes. So there's, I can't remember whether there's an Ant or a Maven plugin that PyTest is integrated with that will use your SCM and only run tests that are touch code that has been modified since the last check-in. So the mutation testing can take a long time, so you can use fewer mutants. So as I've already said a couple of times, that set of mutating operators, you can modify that and you can reduce it if that becomes, it seems advisable to you. You can filter the candidates. So again, I was talking about class paths. You can do it by package, you can do it by class path, you can actually do it by class. So you have control over the areas of the code base that you want to subject to mutation testing. You can run less frequently, which is what I meant, maybe not on the desktop at the build, maybe not at the check-in, but at the, a downstream part of the pipeline, maybe on a nightly build. Or we can get the developers to run mutation testing, and they can run the mutation testing only on the code that they're working on, which I think plays to the point that you were making. It's only the code that actually is changing that is, maybe not only, it's more beneficial to run mutation testing over the code that you're actively working on. It's good because you get that faster feedback. So it's another form of design feedback. It tells you things that maybe you wouldn't have seen, that maybe your peer or your pairs didn't see or wouldn't have seen, and can help to improve the design of the code. We've really talked about that. So the CI server can run the whole, but here we go. There's SCM integration, which is it's documented on the website. I can't quite remember which tool it's integrated with, which build process. I would need to go and have a look. But there's an SCM integration. It's not maintained by PyTest. It's something that has been used from outside, and PyTest is integrated with it. And so it uses the diff, essentially, the set of change sets to decide which tests to run. So, experience and recommendations. So I think I've already said this. So the easiest and most effective way to use mutation testing, in much the same way as the easiest and most effective way to use lint, is all the time and from the beginning. Because otherwise you just get that big backlog of things that you need to fix up. When you're getting used to it, it's always good to start small. So I don't know whether any of your organizations have found this, but large projects tend to go a lot wronger than small projects. So if you're going to start something new, it's always good trying it out somewhere safe. Has anyone used CyberDojo? No? You've used it. Excellent. So I encourage you to come and speak to Shika afterwards and find out how great CyberDojo is. CyberDojo is an online tool that provides 30-odd languages and 50 different katas for you as teams or individuals to work through. It's wonderful in so many ways because it is. It's really simple. You can go and do a bit of practice of coding anywhere that you've got a browser. You don't have to install all the packages and the libraries. It has all sorts of esoteric languages and frameworks in there. And it has just occurred to me as I was doing this session that I should probably put Java and PyTest up there so you can go and play with PyTest there. So we'll probably do that in the next week or two. But meanwhile, I would like you to think, if you've got a pen and paper, write down Cyber-Dojo and have a look at it when you get home. The nice thing about it is because you can have up to, I think it's 9 teams working together on the same problem. And then every time you run the tests, it commits and keeps the state of each code base at that time. You can compare every team's journey and see how different people in your team have worked in different ways. And so you can use it as a really good learning tool, a really good learning opportunity. And that is a very small code base. It's got a one level file system. If you get more than 10 files, you've missed the boat. We find that if you keep the number of unit tests per class low, and of course the concomitant and corollary of that is to have a small number of unit tests per class, you have small classes, right? So if your class is big, if it has loads of behavior, then it should have lots of unit tests. But there's a bit of design feedback there saying maybe we should have several smaller cooperating classes. So if you keep the numbers low, then it means that when you find the mutant in there, we only have to run a very few tests because they are the only ones that run over that class. And so this will aid the heuristic to keep the runtime down. And so of course that leads on to having small classes. Now this is I think I've already nailed my colors to the mast when it comes to which tool I think we should be using. So, but you have to select a good tool. And this is Philip that's talking here. And he says the tool needs to be configurable, flexible, and one that identifies the surviving mutant. Now you might find this strange, but there have been tools out there that just go, there was a mutant, it survived, and you're left to guess where it was. So Philip goes on to say, when the tool tells you that a mutant has survived, believe it. So it's akin to saying, there's a bug in the compiler, right? Nope, there wasn't. So I wasn't working with PyTest at this time, I was working with a .NET version, which was called, I'm afraid it was called Ninja Turtle. So there you go. It was called Ninja Turtle, and it was telling me there was a mutant, and I couldn't, that was surviving. I just, where? And it turned out that it was creating a temporary class, and then it was doing mutation in that constructor. I wasn't using it, and telling me it had failed, and I had to inline it, and it was very painful. But the tool was right. It had found a place in the intermediate code to generate a mutation that I wasn't testing. And I fixed the problem. Now, it is arguable whether that was a good thing to fix, but it made me think about what the lifetime of the object was, what was actually going on. And it did lead to a more compact solution. I've talked about continuous integration servers. I spend a lot of time going into client sites, and one of the things people call me into is to do on a regular basis is a sort of agile health check, so probably agile TM health check. And strangely enough, one of the first questions I ask is, can I see your continuous integration build server outputs? And maybe you wouldn't be surprised. I'm constantly surprised at how many of them are at red, as in failing on a regular basis. I went into one bank earlier this year, and I said, oh, that one's red. I said, yeah. How long has it been red? 5 months. It's like, why? Oh, well, the test passes on the desktop. So what we have is we have a culture of people who try get as far as finding out that the problem is either difficult or spurious, and then ignore it. And effectively, at that point, your continuous integration build is a pointless waste of time, because it gives you no information. The same goes for mutation testing. If you stop doing mutation testing because you get to a point where you're getting a lot of reports, then the issue is not that the mutation testing is broken. And if you turn mutation testing off or stop responding to it, then you will get back into the place where you have 20,000 warnings on your lint, and you won't ever fix it. And I'm sure you've all been through this cycle a lot of times, that you start off doing something good, you stop for whatever reason, and it's really hard to start doing it again. So the same goes for eating sweet foods, smoking, you name it. There are an awful lot of habits out there, and mutation testing is just another one of them. It's good for you, but it takes effort. And if you leave it for too long, then it becomes insuperably hard to start doing it again. This is a good one, less code. I can't even remember who told me this, but software is a liability. That's the quote that I'm wandering around with in my head. The less software you can have, the better. Liz Keogh, I think, says it nicely. She says before she lets any of her teams ever write software, she asks them, how would we do this if we had an infinite number of pixies? And I think that's an interesting question to ask, because very often there are other ways of achieving the same thing, and you may get to a point where you can have something that satisfies the customer as well, if not even better, but with less code. So code is not good, you ain't going to need it, etc., etc. More unit tests. So it should come as no surprise that given that the mutation testing library is something that checks the quality of your unit test suite, that having more unit tests is going to improve your chances of killing mutants. But also it's worth thinking about what those unit tests do. So I mean, I don't know what sort of unit testing folks do here, but I have a set of principles that I stick to and that I train to. There are a number of excellent books out there on the subject. Emily Bates herself has got some wonderful work on what unit tests, or the good properties of unit tests. Roy Osherove in his seminal book, which is now in its 2nd edition, also goes into details of what should be a good unit test. And of course, Michael Feathers has got things to say about what sort of tests aren't unit tests. So there's a lot of work to be done to try and keep the unit tests good. The challenge is not to make sure that you kill mutants. So let's put this in its right context. Mutation testing is about verifying the quality, or one aspect of the quality of your test suite. And the quality that it's verifying is that it covers the behavior of your software. But that is by no means the only, and possibly not the most important, facet of your test suite. So I've said it already today, and I say it on a regular basis. I believe that documentation for your developers is the most important facet of your test suite. It's the place where you can go and get an absolute source of truth. Because if it failed, it would be red, and if your CI server is green, it means it's running and it's passing. So it means that your documentation, your tests, are in time, up to date, and in sync with your application because the tests are running and passing. And my example is always to cast it back to the audience. Have you ever read a comment in your source code that was incorrect? And the answer is, of course you have, because it happens all the time. Have you ever read documentation that referred to something that no longer exists? Of course you have. And
Surely on that, since you must have asked the question, have you ever read it, especially in an integration test?
Yep. No, and this is the point. Absolutely, you're right. But so it can be misleading, but it's passing. So the truth may be expressed poorly, but
The truth may not be expressed at all.
okay.
The key assertion may be incorrect or which mutation testing goes to.
So what we're doing here is we are trying to make sure that there's validity there, but the tests themselves, when they are valid, give us a source of truth about what is running against. So I mean, the things work together, but if I had a choice between 0 mutants and a well-documented test suite that documents my application well, I'm afraid I would still go for the latter. But no, I take your point. Until you get them to a good point, you can call the test anything you like, you can run anything in it, and you can assert nothing at all, and it will still, it can be misleading. Yeah, fair point. So available tools. In Ruby, there's Heckle and Mutant. I think Mutant is still under development. Heckle, I think, is long gone into mothballs. Java's got PyTest, Jumble, and Jester. Jester, I believe, is also in mothballs. Jumble, I believe, is in mothballs. PyTest is under active development. Henry's been doing a release every 3 months for the past 3 or 4 years. It's gone from 0.33 through to 1.1 over the past year and a half. C# has got Nesta, Ninja Turtle, Cream. Python has Pesta. Obviously there's a Wikipedia page which lists them all. So how many of you work in Java? Oh dear. How many work in .NET? That's what I thought. So I'm afraid the news I've got for you is not good. Right? They are all rubbish. Okay, none of them live up to PyTest's functionality or operation. I've had no end of pain working with Ninja Turtle. Cream is slightly newer, and I haven't yet used it in anger. And I don't generally work at the MSIL level of the abstract syntax tree of C# or whatever. So I don't know what whether there are intrinsic problems in the .NET landscape that prevent a PyTest-like implementation on the .NET stack. I would be really ecstatic to hear if any of you go off and decide to implement one, because it's, I hope if all I've done today is shown you that there is a tool that can help us validate the quality of our test suite. I'm hoping that at one point somebody on the .NET stack will become sufficiently excited about this to actually go out and to try and do a good job. So I know for a fact that Henry would be happy to work with anybody who wanted to do this. And the architecture is going to be similar as Java and C#. They almost even look the same. Maybe we can just get a cross compiler, a very angry compiler. So the tools are there. PyTest is the gold standard, as Henry calls it on his own website. It's the gold standard of mutation testing libraries. And the .NET ones so far haven't measured up. A number have been started. The guy who was doing Ninja Turtle stopped doing it 3 years ago when he changed jobs, and he's been very difficult to contact. Cream, as I said, is new, and I haven't tried it. If you do get around to trying Cream, I would love if someone would fling me a line to tell me if it's any good or not.
Started again in June.
Which one did?
Ninja Turtle.
Did it?
Posted on the site.
Okay. Excellent. Well, I'll maybe go and have a look at it again. I did actually get it working at one point, but not reliably. I was running a workshop in Rotterdam, and I had mutation testing libraries in Ruby, in Java, and in C#. And on the day, the C# ones would work on some people's machines and not on others. So this is PyTest. Actually, I should add this. It works with Java 8. It works with all mocking frameworks. It integrates with Maven, Ant, Gradle, and SBT. Plugins for Eclipse and IntelliJ, for Jenkins and SonarCube. So, under active development, loved by its creator and many of the people who use it. So it's not a niche thing. It's not an open source product that nobody's using. So Sky are using it in Livingston. I don't know who the ladders are in New York, and we have a number of insurance companies, investment banks, etc. Philip van Lernen, who I gave credit to at the beginning, worked on Norway's e-voting system, and they used it as part of their development process. So we can be proud. It's designed and made in Britain, and this being, it's actually designed and made in Scotland. So, and so I'm coming to the end of my session here. I'm afraid the last thing I have to do is a plug for myself. So I spend a lot of time working in the Cucumber team as well, and we've just finished writing this book, which is now in beta. So if any of you are, well, it sounds like none of you are working in Java, so Owen, you can go and buy the book. So thank you very much. It's in beta now. That's me. I'm happy to answer any questions. Thank you very much for sitting through this.
What are the kind of, are basically most of the mutants working on conditionals?
So there's maths mutants that will change the actual values you get back. Some of them, so for instance, the void return method will actually take the void return method call out. So there are other things apart from conditionals.
So well, I guess if you follow the kind of self-documenting code principle where I is less than or equal to 100, you'd actually replace that with a method call that says check that something is less than or equal to 100.
Yep.
And passing an I. Will it then work out that in that conditional, that method call is actually the thing that you use to mutate?
So what it does is it won't work out in that method call, but it will find that method and mutate that method.
Right.
So it basically goes through the entire compiled code, and it looks. So I'm not part of the implementing team, so I'm not entirely sure what the implementation is. But my guess is it looks for all comparisons and a number of different maths, and that the things that it looks for are related to the mutating operator that you're currently considering. So each intermediate language step or phrase, instruction, it will go which mutation operators could be applied here, and it will then apply the ones that are relevant. Yeah.
Any comments about the quality of Pesta?
I don't have any comments about the quality of Pesta. No, I'm sorry, I've not used it. Owen, have you? Oh no, Python. So I'm afraid no, I don't work in Python. So I haven't worked with anyone who did use it. Although I think I should be able to say what we can infer is that it started off with Hester, which then got ported to Java and Jester. So I'm assuming it's a port of that, and that didn't have originally any of the heuristics to use coverage to reduce the test suite. And I don't know what is Python not an interpreted language? There is an intermediate bytecode. Okay. So actually, maybe what you should do is liaise with Austin, who does a lot of Python type work, and maybe you'll have a look at Pesta at some point. So there we go. Sorry, what was your name? Kit. Austin. Yeah.
You've talked a lot about the way you use this with unit tests.
Yeah.
Do you ever see a way to use this with regression tests?
So test naming is such an interesting area. So what's a unit test is a great question that I still struggle with when people ask me. And a regression test, is a unit test not a regression test?
Well, for us, regression tests are end-to-end tests.
Okay.
They go right through our system.
So I can see you wanting to do mutations. The issue I think I'd have, and the issue that I have with all end-to-end tests, is that they're typically brittle and they're typically slow. And so if you're going to have, so where would you do that mutation? And if you did then do mutations on an entire system, you'd end up with thousands of mutants. And then you try to run even just one test case through that, which could take many seconds, especially if you're using UIs. So I'm not sure that I see the value there, but it might just be that I haven't thought about it deeply enough. Were you going to say anything there, Owen? So you.
Six on the same comment, which I don't think this will work so well with the tests for the original.
Yeah.
The code base that people take is really something that's capturing the test of it. So I think
So I'm not even sure though that so the way that I think about the testing pyramid, you've got lots of unit tests at the bottom, and the higher up the stack you have less tests, and they test more of the application stack. And the way I think about it is the way it was in fact Goiko Hadzik that told me about this about 3 or 4 years ago, and he said, the test at the bottom tests the little building bricks and the business logic that that you can decompose, and the further you get up, what you're testing is the interaction between them, not actually their behavior. And what mutants are doing is going in and affecting the behavior. And so that can be covered, and covered well, I believe, down at the low level base component. Whereas when you get to the top, typically I'm looking for, have I installed it in the right place? Are the firewalls working? Is the configuration file correct? And so potentially there's scope for having a different sort of mutation library that is focused on Spring, I guess, or is focused on some sort of Java type properties file or some C# injection framework that goes in and changes the XML or something like that, and then tries to run the whole end-to-end test. But
I don't think this to be technical.
okay.
Configuration. The way I'd see it is in our systems you have one tier messages into another tier.
Yeah.
Interactions with data stored back again. I can see conceptually the implementation testing at the interface points.
Okay.
But again, I just think technically to make that work, it's a much bigger problem than things like this. Part of these workloads that they can constrain the technical domain.
Yes. Well, so even with PyTest, which works in Java on the JVM, it doesn't work with Scala on the JVM. It doesn't work with Clojure on the JVM. It doesn't work with Groovy on the JVM. There is actually, even on the JVM, there are significant differences to the bytecode that gets generated that makes it hard for Henry to port it to other generators.
Is there any work, maybe just academically, but work that takes the output of the mutation testing and suggests the tests that are missing? And I'm wondering because that might be a way to start to apply this to legacy code. You run it all, you get all these suggestions about tests, and then you run those tests and actually things start to work. Maybe that's a way to bootstrap a legacy system.
So I have spoken to people who have been talking about trying to do that with plugins. They were academics, and as yet I haven't seen anything. The other person that I was speaking to about it was the quick check people, who've got, it's an entirely different tack of trying to generate test cases, but it's another interesting one. So I have strict instructions here that I'm not allowed to let you overrun into coffee break. So thank you very much for your time, and I'll speak to you. Trust the code, the test suite that you've inherited. It doesn't mean that the tests are effective. So when I have another hat on, I do a lot of training of people in how to do good unit tests and how to work in a test-driven way. And I see an awful lot of modes of operation that I think lead to verbose, incomprehensible, and unmaintainable test suites. And coverage isn't going to tell you anything about that. So in fact, you could have one monster test that called every method in your application. You could have no asserts in it whatsoever, and you could get 100% code coverage. So definitely not. It won't tell you when you've done enough. So a lot of customers work with legacy code. Are people familiar with Michael Feathers? He has a wonderful definition of legacy code, which goes, legacy code is code that doesn't have good automated tests. And that covers most of the code in the world, including the code being written today. So it'll be legacy code as soon as it's committed. And one of the problems that I see regularly is that people go, I've got this huge code base, it's got some tests, I don't know if I can trust them. How am I going to change this really important part that the business wants me to expand, modify, make more generic. And they go, well, I'd like to put some tests around it. And that's great. Let's try to put some tests around it. So we go off to Michael Feather's canonical book, Working Effectively with Legacy Code, which I wish I was on commission for, and it should be on everybody's desktop or bookshelf. And it's got hundreds of patterns about how to work effectively with legacy code. But if you read the little bit at the beginning, he talks about, in most cases, you have to perform some safe refactorings without having the benefit of those automated tests. Because even to put the thing under test, you have to change it a bit. How your tests measure up against your code. And it's hardly used, and when it is used, it's used badly. It's sometimes used inappropriately by management to beat people around the head. It can be used to break the build if it's not going up, which is also just beating people around the head. And then it's one of those laws of unintended consequences. If you force people to make the number go up, the number will go up. But whether you'll get anything out of it that's any use is not a great thing, is not assured at all. So these are the things that we say at the moment. Potentially peer review will catch these things, but most of the others are not going to assure the quality of your test suite. And certainly if you're taking on somebody else's product, you're looking at something open source, or you're trying to buy something in, or you move to another team and you want to work out whether something's good, there's very little to give you any confidence that the test suite is useful, correct, or working. For me, for my part, I think this test suite is the best form of developer documentation. And so if I can't go to it and rely on it and get a feel for what the system does from it, then I think that we're missing something. So I think there should be, I always hope that there will be other ways of determining the quality of the test suite. So let's focus on code coverage to start with, because I'd like to, I really want to take this one apart right at the beginning. So code coverage itself is a sort of umbrella term for many different things, which includes line coverage, branch coverage, statement coverage. So there's all sorts of different coverage. And in fact, if you compile things down into binary or into some intermediate language, there are even more points there at which the coverage could be analyzed. And so this code coverage, does it guarantee that you can safely refactor your tests? So if you've got high code coverage, in the 90s, does that mean you can refactor things? No. We've got a man shaking his head in front. Not at all. It doesn't mean either that you can. So that's a really dangerous thing. So you want to do as little of it as possible. How are you ever going to be sure that you've done enough there to protect that legacy code so that you can go in and modify it? So coverage doesn't help with any of these things. Animation doesn't. So it tells us nothing about the quality of our tests. It tells us which statements have been run by our tests. So it doesn't even tell us that we've tested those statements. It tells us that we've executed them. It tells us which statements have not been tested. So from that point of view, code coverage does give some important information. It says this area of the code has definitely not been tested. So it's a negative. It's saying this bit is really, really awful. It's so awful that you haven't even been there. But the bits that it has covered, it tells you nothing at all. Just means that you've run something. So I've really dissed coverage because I think it's important to diss coverage in the same way that Alan did a wonderful dissing of Agile certification this morning, because it's generally accepted as a useful number, and I think it's almost, it's worse than useless in most situations. However, it is extremely useful. I will tell you about what it's useful for later. So this is the suspense, this is the hook, this is the draw to stop you from walking out. I will tell you what code coverage is useful for later. Here is a very simple class. What does it do?
Provides greater than equal to 10 increments a internal variable.
Yes. Test. Do any of you use TDD? Some. So we often hear as well that TDD will protect us because TDD says you never write any code unless you've got a failing test. So any of you that practice TDD will know that it's really hard to slow developers down. They see loads of things that they want to do and they don't wait for the failing test to be there. And anyway, just because you wrote the test first doesn't mean the test is good, is well considered. Peer review is, as was mentioned by the audience, that's, that and pair program both work together to try and help keep the quality good, because you've got at least another pair of eyes looking at it before it gets committed. This is one that is very common, which is QA was going to catch any problems. Now, that's obviously not keeping your code, your test suite high quality, but at least it's trying to keep stop defects from escaping into the consumer's arena. I saw an excellent little joke article not that long ago about a development method known as stack trace driven development, where you don't have a QA team, and you just release the code, and people just send you the stack traces, and that way you know where your next piece of functionality has to go. And finally, good code coverage. And this, I would say, is probably the most common answer. So how many of you have got a continuous integration build or something of that sort? And how many of you have a coverage statistic that pops out the bottom of it? And of the 4 people that have got that, what do you do with it? Okay, nice number. Nothing? We don't let managers look at it. So it's a metric that, it's probably the only metric that's well known about how your test. This session couldn't have been put together without the assistance of these 2 gentlemen. So Henry Coles on your left is the inventor, creator, and maintainer of PyTest, which is a package that I will be showing later on in the demo. And Philip Van Lenen works with a Ruby version called Mutant, and he's an advocate in I think he's in Norway. So these guys, massive thanks. They helped me with this material, and they created the tools which I use. So I've been talking about the quality of tests. And so before I actually go into any detail here from me, I'd like to know just a little bit about you. So how many of you consider yourself to be developers? Pretty much everybody. The people that didn't put up their hand, what do you consider yourselves to be? How do you describe yourselves? Architect? That's it then. Okay, 1 architect, there's a lot of developers. Do you feel outnumbered? No, you can't see them. This is normal, okay. So how do you assure the quality of your test suite? So I guess maybe the question that comes before this is, do you have an automated test suite? So how do you know how good it is?
Peer review.
Peer review, okay.
Code coverage.
Code coverage.
Review with business.
Sorry?
Review with the business.
Okay, review it with the business. So one of the things that quite often we jokingly say is that we only employ really good people, and that means that we're always going to get really good codes.